chapter A. And chapter A is on physical quantities. And units. For A1, the first part of the chapter, we'll talk about physical quantities. Now, a physical quantity is one where you make a measurement, have a number, and you have a unit. Or maybe you calculate that from some other measurements. So we have a number followed by a unit. Example would be, say, let's take distance. We could have 5 meters. So the physical quantity is distance. The number here is 5. And meters would be the unit. Here's a picture from NASA where 2 employees are in the photo. One is measuring a viewing height. The other is in a space suit. So height would be another physical quantity. Here from the ground up to the viewing height. Another example here is one involving time. This is age. So we can think of age as another physical quantity. Say if someone's in high school and they say they're 16, it would be understood that it's 16 years. It's always good to include the units with the number to avoid confusion. For example, here with my grandson, if I said he's 5, well, like, what do you mean? Like 5 weeks, 5 months? You probably could figure it out that it was months in this case. Like 5 days is too short. 5 years, like no way. But it's not good practice to have to guess what the units are. We should write them down. One example, when they were not written down and there was a failure in NASA where millions of dollars were lost, something like $330 million, the Mars Climate Orbiter burned up in the atmosphere because when one value was transferred from one like office to another, the units weren't present and wrong assumption was made because see, we have different kinds of systems. For example, you have the British system where you might see feet or yard, see, or miles. Then you have the metric system where instead you would see things like the meter, say, or the kilometer. So it was one of these kind of miscommunications where the unit was not included. Here's what NASA said. The mission, say, quote, was unsuccessful due to a navigation error caused by a failure to translate English units to metric. Jet Propulsion Laboratory, Caltech. Another example of a physical quantity is weight. And here my wife's on a scale. So weight would be another one. And in the US, we often just use pounds. So for example, you might have something like 120 pounds, like that. Let's take a moment to talk about two physical quantities that are close to each other but not identical, and that is mass and weight. Let me put time in here so we have the time. That would be like age. And then mass and weight. So these are not the same physical quantities. This physical quantity, mass, refers to how much stuff there is. And if you take a suitcase and put it on the moon, you'd have the same amount of stuff there that it would be on Earth. But if you put it on a scale, it would weigh more on the Earth. The Earth pulls down more than the moon would pull down. So, for example, on Earth, if you have 120 pounds, reading on a scale by standing on it, if you were on the moon, like if you had a box, with stuff in it, and it was 120 pounds, and then you went, to the moon and had the same box, it would weigh 1/6. So it would weigh 20 pounds. So on the moon, we're looking at 1/6. So the mass is the same, since that's the amount of stuff, but the weight would be less. And we'll make that distinction again in our course as we study mass and weight, forces, Newton's laws, gravitation, all kinds of neat stuff like that. So mass, proper units for mass would be the kilogram. And the kilogram, if you put a kilogram, I'll say 1 kilogram on Earth, that's going to weigh 2.2 pounds. Now here we're looking at two different systems of units. This is metric and this is the British system. But just to illustrate, if you take the 1 kilogram on the moon, it's still 1 kilogram, but the weight, you'd have to take 1/6 of it. So one way to fix the kilogram usage as a weight, you could say that if I really want to talk about the weight, I could say 1 kilogram weight. So this is saying kilogram weight. The little dot just means or you can put a dash if you want, but here I like to use a little dot. But here, this is actually a new unit, and maybe we could write it like this: kilogram, weight, like just make a longer word. So the kilogram weight is a unit that's together that refers to the weight of 1 kilogram on Earth. Here's a cool picture I found from Flickr where a cat is on a scale. And I like to analyze this picture for a couple of reasons. One, sometimes measurements are not direct. The cat here is blocking the scale reading over here. So this is a challenge, and in physics we like challenges. So if you take, this is 0, like here, and then you were to have the same angle, so on the other side, these numbers you can read. Now, a little bit hard to see here because they're small, but if you were to look at the numbers down there, on this side you have 0, 280, and 260 in pounds. And this red one is where the needle is going to where the correct value is, but it's being blocked. So you really can't see the number here. But by making this angle the same on either side, where there are numbers, you can then look at this and say, well, this is click, 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 that's 30 pounds and a little more. So it's, this would be roughly 30 pounds. And if you look a little more carefully in the book, it's more like 34. So that's an indirect measurement, but then there's no way a cat weighs 30 pounds. This is a joke. This is put on there as a joke. Hey, I don't weigh this much. The cat saying something like that or thinking something like that. And here, if you look at the scale, some of it is outside the picture. And that, is possible. See what would happen there with the owner, pushing down on the edge, which you can't see. That would explain, the cat having a weight of 30 pounds. Well, a cat typically be 10 pounds, 10 pounds more reasonable. So two things, sometimes we have to do some clever analysis to figure out something in physics. And then second, in engineering or physics, we have to, we should always ask ourselves if the answer is reasonable. And 30 pounds is not reasonable, especially if you're looking at the cat and you see that cute cat is not 30 pounds. All right, we'll move on to the next section where we'll give you a guide in solving problems in physics and engineering.